The last chapter that we have to cover in the class, so chapter 18 is the last chapter, so we're on that downhill slide. We see the light at the end of the tunnel. So 18.1 is about solving quadratic equations by completing the square. And what you'll notice in all the sections, guys, is that chapter 18's different ways of solving quadratics other than factoring. So up until now, when we got a quadratic equation, we would just factor it. But if we couldn't factor it, we would just be stuck, and we wouldn't know what to do. So chapter 18 is different methods that you can use in order to solve. So like up until now, on number 1, you see a quadratic, your first instinct would to be subtract 50 over, so you have x squared minus 50 equals 0, and then try to factor it, but it's not factorable, so you would just be stuck. So what we're going to learn today is completing the square. And the whole idea of completing the square is that we can use the square root method. So before we get to completing the square, we're going to do 1, 2, and 3 that talks about the square root property. The square root property says if you have a square equal to a constant, then you can just take the square root of both sides, okay? We did it before when we had to do the Pythagorean theorem. The only thing that's new is that we have to realize that when we square a positive, it equals 50. But when you square two negative numbers, what happens when you square two negative numbers? It's still a positive 50, okay? So when we take the square root of the right-hand side, right in front of that square root symbol, we're going to have a plus or minus symbol, okay? So we're going to take the square root of the left because square and square roots undo each other. But over here, we're going to put a plus or minus square root of 50. Because not only do two positives multiply to be a 50, but two negatives multiply to be that positive 50. On the left-hand side, what happens with the square and the square root? Yeah, it's just an x. They cancel each other out. They're inverse operations. Over here, though, how does 50 break up? That's 25 and 2, or 5 and 5, right? So who can come out? The 5, who has to stay in? The 2, but realize what's in front this whole time, a plus or minus. So we have plus or minus 5 root 2. What does that mean? My math lab actually has the plus or minus symbol for you. They used to not. Like, we emailed about it. So on my math lab, you can put the plus or minus symbol in 5 root 2. But realize the plus or minus symbol means we have two answers, okay? X equals negative 5 root 2, and x equals positive 5 root 2, okay? Those are two values that when you square each one individually, you're going to get 50, okay? And I'll show you how you can check that, which is kind of nice, okay? So writing it this way and stopping there, it's fine, but I just want you to realize we found two answers. So on your calculator, if you put in parentheses negative 5 square root of 2 like that, so there's our answer, okay? If we plug it back into our original equation and just square it, we get 50, right? And if we just do the same thing, but get rid of the negative symbol, so we just square 5 root of 2, you get 50, okay? So before, we wouldn't be able to solve it, so like, okay, 50 is not a perfect square, how do we go about, breaking it down? But now we know how to break down radicals from chapter 17, so we can come up with the correct answer. All right, number 2, believe it or not, is just like number 1, but we have to get the squared isolated first. So the x squared needs to be isolated. So what's the first move we're going to make?
14.
Add the 14 over. So we have 2x squared equals 14. Is that okay? What do I still need to do? Divide by 2, right? So we're going to divide by 2. So x squared equals 14. So we had to do two things. We had to move the 14 over by adding it, and we had to move the 2 over by dividing it. But now we have exactly what we had in number 1. We have a square equal to a constant. So how do we undo the square? We take the square root. But on the right-hand side, don't forget to put a plus or minus. Oops, are you guys questioning that? Because 14 divided by 2 is not 14. Yeah. I was like, I saw people looking at it funny. They're like, oh, it's 7. Okay, so 14 divided by 2 is 7. So we're going to take the square root of x squared, but we're going to take the square root of 7 as well. All right? What happens with the square and square root? They undo each other. So an x pops out. Can we break 7 down any further? No, so it's just plus or minus 7. And again, you can stop right there, because my math lab has that plus or minus option. but realize you found two answers, okay? If you square root 7 and multiply it by 2 and subtract 14, you'll get 0. If you square negative root 7, it's the same thing. And I usually check the negatives, because if the negative works, then the positive works. So I go to my original equation, okay? So my original equation had 2, so I have 2 parentheses, negative square root of 7. I close off my parentheses for the root, and I close off my parentheses for the negative, and I square it, minus 14. So see how I'm just typing this original equation, but in for x, I'm putting negative root 7. And when I hit enter, what do I hope to find it equals? 0, and that's what we wanted, okay? So go all the way back to the original, because if you go to any step other than the original, it may still work because you did the math, incorrectly. All right, number 3, believe it or not, is exactly like number 1. Don't we have something squared equal to a constant? We do. It's not a simple x, but it's a quantity x plus 1 squared. So since this is already isolated, some people might say, well, there's a 1 there. Yeah, but the 1's part of the square. The square is already isolated, okay? So since it's already isolated, we'll take the square root of x plus 1 squared. But if we take the square root of the left, we need to take the square root of the right, and we've got to put a plus or minus in there. Because whatever's in that parentheses might be a negative, but when we square it, it'll equal 12. Or whatever's in those parentheses might be a positive, when we square it, it equals 12. On the left-hand side, we don't worry about the plus or minus. The square and the square root will undo each other, so x plus 1 pops out. On the right-hand side, how does 12 break up? I do 4 and 3. Why does that help me? Because 4 breaks into 2. So who can come out? The 2. Who has to stay? 3. So we have plus or minus 3 root, not 3, the 2. 2 root 3. Does that look right? Okay. So we have x plus 1 equals plus or minus 2 root 3. But we're solving for x, so what do we still need to do to get x by itself? Minus 1 over. He can go anywhere, but for purposes of this class, always put that constant right in front, and you'll see on Wednesday why, okay? So when we subtract him over, he's going to be negative, so we have x equals negative 1 plus or minus 2 root 3. Why can I not combine them with the 2 root 3?
They're together.
Well, the root 3 is a root 3, right? The 1 is just a constant. These aren't like terms, so we can't like make it 1 root 3 or whatever, So this is your final answer. But again, as weird as it is, realize we actually have two answers. This is actually x equals negative 1 minus 2 root 3. That's a number. I know it looks weird. Negative 1 minus 2 root 3 is a number. Or x equals negative 1 plus 2 root 3. I know it looks weird, but that's an actual number. We kind of are judgy. We're like, oh, that's not very pretty. So I'm going to go back to my original equation again and just try it out, okay? So in my original equation, I have parentheses, and then I have x. What is x? Negative 1 minus 2 root 3. Close off my parentheses for the root, but then I still have to add plus 1 to it and square, okay? So here's x plus 1, the quantity squared. When I hit enter, what do I hope it equals? You guys can't see that, can you? There he is. When I hit enter, it equals 12, okay? And usually if the negative works, the positive is going to work. So here, as ugly as it is, there's my x plus 1, okay? There's my x plus 1, quantity squared, and when I hit enter, I want to equal that right-hand side. So I know you don't feel this way, but anytime you have an equation, you can always check your answers. All the other stuff that we did, adding, subtracting, multiplying, dividing, you don't know if you're doing it right. There's no way to really check it. But equations, anytime you have an equal sign, you can always plug your solution back in to make sure it works, okay? So these are ways to solve quadratics when they're not factorable, okay? So these are ways to solve quadratics when they're not factorable, all right? So it would be nice if everything was just a square, because all of these are missing the x term. Does that make sense, guys? This is just x squared and 50. This is just x squared and 14. This is x plus 1. We don't have that x term, that middle term, where we can use the AC method. So if everything was a perfect square, like this, we could just do the square root property all over the place, okay? So that's actually what completing the square is all about. So it says, given something where you do have an x term, what the heck do we do with it? It says, given the first part of a quadratic, x squared plus bx, what we're going to do is we're going to find half of b squared, and I'll show you why it works, okay? If we add this to the original equation, we will have this little chunk here, which means, if you look at it, we could use the square root property, okay? If you have a minus sign, it's the same idea. Still find half of b over 2, but the minus sign will be in there. And I'll talk to you about why it happens, okay? So let's kind of just go through the motions. The first thing we have to do is find b over 2. So what I do is I say, okay, we have our x squared, we have our 2x. I'm going to divide this guy by 2. And I show it. I actually divide by 2 right there. What is 2 divided by 2? 1. And we're not going to worry about the x. We're just concentrating on the numbers, okay? So 2 divided by 2 is 1. So I put that right there. Is that what they want me to add here? No. What do we still need to do? Square it. So I'm going to add 1 squared there, okay? Well, what's 1 squared? That's not anything special. That's just 1. And you're like, Molly, why did we do this? What we're doing is we're forcing any quadratic to be a perfect square trinomial. What was a perfect square trinomial? It was when you factored it, the factors equaled each other, okay? So think about it right here. If we had to do the AC method to factor this, what are factors of 1 that add up to 2?
1 plus 1.
1 and 1, right? And so what would this factor to? X plus 1 times x plus 1. What's another way to write x plus 1 times x plus 1? X plus 1 squared. Okay? It is a shortcut. What we're doing is we're writing this, we're adding a constant so that it will always factor to a perfect square trinomial. Okay? What we're doing is we're adding the correct constant that no matter what, it'll always factor to a perfect square trinomial. What's another way to write that trinomial is x plus 1 squared. And you're like, well, why do we want to do that? Because if this is in our equation, we'll be able to take the square root of both sides and we'll be able to be done. Let the sign follow you. If it's not an even number, that's fine. We can still handle it, okay? So let's look at 2. What are we going to do with 2? We are going to divide the b, which is 12 by 2. What is 12 divided by 2? 6, okay? Is 6 what I add to this line? No, I want to add 6 squared. What is 6 squared? 36. And again, what's the whole point of that? If you look at that equation, what are factors of 36 that add up to 12? 6 and 6. So your answer, you're like, how do you know what to put in there? It's always b over 2, okay? It's whatever we write right here, okay? So what was half of 2? 1. So we put x plus 1 in there. What was half of 12? 6. So guess what this factors to? This factors to x plus 6 times x plus 6, right? But the shortcut is we should just know it. It's just going to be that number right there, okay? All right, last one, number 3, guys. What do we have to do? We have to divide the negative 10 by 2. What is negative 10 divided by 2? And keep that sign in your head, okay? So what we're going to do is we're going to keep the negative 5 just like that. Does it affect what we add? No. Whether you square a negative or square a positive, you're always adding the positive, okay? So what is negative 5 squared? It's going to be positive 25, right? Because negative times a negative is a positive. And then I ask you, what are factors of 25 that add up to negative 10? Negative 5 and negative 5, okay? So what's going to go right here is just x minus 5. So whatever half of the middle term is, including the sign, is the factored part. All right. You're like, what is the point of this? Why do I need to be able to do this? Because we're going to do it to legit equations. And what we're going to do is we're going to make the left side be these perfect squares so that when we take the square root, we're done. Okay? So let's see if we can make that happen. Let's look at the top of the back page. It says, if the coefficient of x squared is 1, go on to step 2. So we need the first coefficient, a, to be 1. If not, what we have to do is we have to divide everything by whatever the coefficient is. So if there's a 2 in front, divide everything by 2. If there's a 4 in front, divide everything by 4. All right, number 2, keep just the terms that have x, the x squared and the x, kind of like what we had right here. See how we just had those two? We're going to keep just those x terms on the left, and we're going to move the constants to the right. And then what we're going to do is we're going to complete the square. So we're going to do the b divided by 2, but whatever we add to the left, we're going to add to the right, and you'll see what happens. So it's easier to just kind of do it. So let's just jump right in with number 1, guys, okay? Number 1, step 1, is my coefficient, first coefficient 1? Yes, so I can go on to step 2. Step 2 says keep only the x squared and x terms here. So who's in our way? Who do we need to move first? That 51, okay? When you move him, leave a gap. So we're going to write this as x squared minus 16x plus blank equals negative 51 plus blank. And all I'm doing is I'm trying to make the left look like those 3 that we did on the bottom of the front page, okay, where we're going to complete the square. But I can't just add 25 or whatever to the left without adding it to the right. I got to keep that scale balanced, okay? So at this point, once you move your constant over and you have spaces to add your numbers, we're going to go ahead and complete the square, okay? So how do we complete the square? You divide b by 2. So what is b in this case? Negative 16. What do you get when you take negative 16 divided by 2? Negative 8. Is that what I add to these lines? No, I add the square to it. So what is negative 8 squared? 64. But if I add 64 to the left, guys, this equation needs to stay balanced. So right now, like, I don't really care what's happening over here, but I have to add 64 there because I want 64 here. I want to keep that equation balanced. Well, what was the whole point of this is that now we have a quadratic, x squared minus 16x plus 64, that factors to a perfect square trinomial, okay? What's this left-hand side factor to? It will always be whatever half of b is, okay? What are factors of 64 that add up to negative 16? Negative 8 and negative 8. So this will factor to x minus 8 squared. And I can just jump right to it. If you want to do the AC method, you can. But guys, sometimes we'll get to weird ones with fractions where like you can't really do the AC method. So whatever half of b is, guys, is always that term that you factor to. On the right, actually do the math. What is negative 51 plus 64? It's positive 13. You can just do that, right? So this is just 13. And guys, what we've done is we've changed the equation, x squared minus 16x plus 51, where we could sit and try over and over again to do the AC method, but there's no factors of 51 that add up to negative 16. We couldn't factor it. But now we've changed it to look exactly like number 3 on the front page. And what did we do on number 3? We said, oh, our term that's squared is already isolated. So let's just take the square root of both sides. So guess what we can do here? We can just take the square roots of both sides. So we're going to take the square root of x minus 8 squared. But if we do that to the left, we've got to make sure we do it to the right and put a plus or minus symbol in front. Because a positive can be squared to equal a positive 13, or a negative can be squared to equal a positive 13.
Look at 13.
Negative 51 plus 64. So I literally just did the math on the right-hand side. Okay? So the square and square root will undo each other, so you have x minus 8. On the right-hand side, guys, break your root down if you can. Okay? Can 13 break down any further? No. So it's just plus or minus the square root of 13. All right? So we're almost done. We almost have our x isolated. What's the one last step we got to do? How do I get x by itself? Add that 8 over. When I add that 8 over, can he combine with the root 13? No. So I'm just going to pop him in front, okay? So this is x equals 8 plus or minus the square root of 13. And those that came in a little late, I was just saying how my math lab used to not have the plus or minus symbol, but now they do. So you can literally type 8 plus or minus root 13 in your calculator, or in my math lab, and be done. But before they had that symbol, you had to write it as 2 separate answers. We found 2 separate answers, guys. X equals 8 minus root 13, and x equals 8 plus root 13. They're 2 different numbers, okay? And what I would say is check one, and usually if one works, the other one's going to work as well. So I do want to check this. I'm going to show you guys how we can check this. And I know it's an ugly number. Let's do 8. I just kind of want to see what kind of number it is. 8 minus the square root of 13. That's 4 point something, okay? It's a number. We're prejudiced because it doesn't look very pretty, but the 8 minus the square root of 13 is an actual number, okay? So what I'm going to do is I'm going to go back in number 1, the very original equation, and anywhere I see x, I'm going to plug in parentheses 8 minus the square root of 13, all right? So parentheses 8 minus square root of 13. but I need it squared, minus 16 times x, but what is my x? 8 minus the square root of 13, plus 51. And what do I hope to find when I hit enter? 0. And it worked. Okay? So we are able to now solve quadratics that are not factorable. Okay? Let's do number 2, guys. Number 2 is very similar to number 1, where the coefficient in front a is just a 1, so we don't need to divide by anything. So what do we need to do first? We need to move him over first, okay? So x squared plus 8x plus blank equals 9 plus blank. So x squared plus 8x plus blank equals 9 plus blank, okay? So what do we need to do in order to complete the square? We're going to take our b, which is 8, divide it by 2, and you get what? 4. And we're going to square it and add it to both lines, okay? So 4 squared is 16, so we're going to add 16 to both sides. All right, on the left-hand side, you can stop and think about it. Hey, we have a quadratic now that we can factor. What are factors of 16 that add up to 8? 4 and 4. You can do the AC method and all that jazz, but you don't have to. Whatever half of b is what goes into your binomial. This is x plus 4 squared. We know it. That's just how the completing the square works. On the right-hand side, you do the math. What's 9 plus 16?
25.
It is 25. And now what we have done is we have written it in a way where we have a square equal to a constant. So we can use the square root method that we learned on the top of the front page. So we're going to take the square root of x plus 4 squared. But if I do it to the left, I have to do it to the right, and then put plus or minus in front of my root. On the left-hand side, your square and your square root always undo each other, so whatever's under there pops out, okay? From the left-hand side, x plus 4 is going to pop out, because squaring and square rooting are inverse operations. On the right-hand side, we have plus or minus what?
5.
5, exactly, because the square root of 25 is just 5. All right, so our last step is to get x by itself, so what do I need to do? I subtract the 4 over. So we're going to have x equals negative 4 plus or minus 5. And you put that into my math lab, and it gives you a red X. You're like, well, what did I do wrong? What you have to realize is when we subtract that 4 over, he's a whole number, and the 5 is a whole number. So we actually can combine them, all right? So that's, and it's going to be 1 and negative 9. So what I do, this is one where I actually do write them as 2 separate answers, okay? So I write x equals negative 4 plus 5, and x equals negative 4 minus 5, right? I'm just writing them as their 2 separate answers, because it's not as easy as 1 and negative 1, right? So I do negative 4 plus 5, that's going to get me 1. And I'm going to do negative 4 minus 5, and that's going to get me what? Negative 9. Does that look right? Oh, it's positive 1, right?
So it's not in the square root, sorry. If it's not in the square root, you can
combine them.
Be a whole
yes,
number.
if they're both whole numbers, you can go ahead and combine them. What does that mean as far as the original equation goes? It means if you complete the square and you get these nice whole numbers, the original equation was factorable. So let's go back and look at the original equation. X squared plus 8x minus 9. What are factors of negative 9 that add up to 8? 9 and negative 1. So you would have factored it to x plus 9, which would have gotten you a negative 9, and x minus 1, which would have gotten you a positive 1. So it's kind of nice to know that, like, if you don't realize it's factorable at first and you just jump to completing the square, you will still get the right answer, okay?
So in that case, we can do the AC method?
Yes, yes. So on my, on the final exam, they'll give you a quadratic and they'll just say solve. The first thing I would do is try factoring, because I think it's the easiest. And then if you want to try any of these methods, if it's not factorable, you can try any of the methods from chapter 18. But yes, you could have done the AC method from the beginning. So these are your 2 final answers. Again, just pick one if you want to just check it. So we have 1 squared plus 8 times 1 minus 9 equals 0. And if you would have done it with negative 9, you would have gotten the same answer. But that is factorable. So that's kind of like a little cheat for when you're doing homework. If you look at one real quick and realize it's factorable, you can get the answers pretty easily. Alright, 3 and 4 are a little bit tougher because what you'll notice is our first coefficient A is not 1, it's 2. And they both happen to be 2, but they don't have to be 2, guys. They can be 2, 3, whatever. Just divide by whatever it is, okay? So when you divide, it doesn't necessarily divide evenly, so we kind of get these fractions, but what's nice is that the completing the square, all the things still work. We just have to do a little bit of fractional math, but we'll use our calculator for that, okay? So we have to divide by 2 first. Divide by coefficient. And I think for purposes of like next year, I'm not teaching this next semester, whenever I teach 116 again, I think I'm going to change one of these to be something other than 2. Because I don't want you to think you're always dividing by 2. You're just dividing by whatever that coefficient is. So like, if this was 3x squared, we would have divided everything by 3. So keep that in mind, because I think on your worksheet, you will get different coefficients in front. Divide by whatever that coefficient is. All right. So, the first one should cancel out completely and leave you with x squared. So we have x squared plus 5 half x, and then I'm going to go ahead and put plus blank equals negative 3 half plus blank. So I kind of killed 2 birds with 1 stone there, guys. I know I want just my x terms in front. So 2 divided by 2 is 1. That's what should happen. If you're dividing by the right number, that should be a 1 there. 5 divided by 2 doesn't divide evenly, so just leave it as 5 half. And then I want that constant on the other side, so since he's positive, I subtracted him over, okay? And I'm going to go ahead and complete the square. And I know it's kind of weird because we have to take a fraction and divide by 2, but we can still do that. So 5 half divided by 2 will get us what? Just throw it in your calculator and hit math frac, okay? So just do 5 half divided by 2 math frac. And what do you get?
1.25.
But hit math frac, so it turns to 5/4. You got it. Just kind of a little tidbit, guys, for quick calculations. Anytime you divide a fraction by a whole number, you're just multiplying the denominator by that whole number, okay?
So you never want decimals with these.
Right. You want fractions always, okay. So what's 2 times 2? 4, okay? If we divide by 3, guys, this would have been 5/6. So it would have been 3 times 2, okay? Whatever you're dividing by, just multiply the denominator by that. All right, so it's not what we want to add to both spots. No, we want to add the square. And again, you can do the square in your calculator, or remember when you square fractions, it's just squaring the top, squaring the bottom, okay? So what's 5 squared? 25. What's 4 squared? 16. So what's 5/4 squared? 25/16. So we're going to add 25/16 to both sides. Alright, so this is where the shortcut helps you. What are factors of 25/16 that add up to 5? We don't know that off the top of our head, but guess what the answer is? 5/4. 5/4 times 5/4 is 25/16. If you put 5/4 plus 5/4 in your calculator, you will get 5. Okay? So we are, or 5 half, excuse me. So we actually just factored it. We know that it's going to factor to x plus whatever b is. So this left-hand side factors to x plus 5/4 squared. Well, whoever's in here, whoever half of b is, just throw them in your calculator. On the right-hand side, we have to do the math. So in my calculator, I'll do negative 3 divided by 2 plus 25 divided by 16, and then I'll hit math frac, okay? Because you want fractions. You don't want decimals. What did you get? 1/16. Okay. So, at this point, it's ugly because it has fractions, but it's what we want. We have a squared equal to a constant. So what are we going to do? We're going to do the square root property. The square root property says take the square root of the left. So we're going to take the square root of x plus 5/4 squared. And if we take the square root of the left, we have to take the square root of the right with plus or minus in front. What happens on the left-hand side, the square and the square root undo each other because they're inverses. So what pops out? X plus 5/4. On the right-hand side, guys, these happen to both be perfect squares. What's the square root of 1? 1. What's the square root of 16? 4. So what's the square root of 1/16? 1/4. Is that okay? So break them down as much as possible. Make sure you have the plus or minus in front there, because there's 2 answers. It's plus or minus whatever the square root of 1/16 is. So So we have plus or minus 1/4 on the right. All right, last thing we have to do is we need to get x by itself. So I'm going to subtract the 5/4 over. So this is x equals negative 5/4 plus or minus 1/4. X equals negative 5/4 plus or minus 1/4.
Negative 1.
We're going to have two answers, okay? So make sure you have a plus or minus in front of your 1/4 there, okay? So we're going to take positive 1/4 and subtract 5/4 from it, and we're going to take negative 1/4 and subtract 5/4 from it. So again, Sadie was noticing that this guy didn't have a root, so we can combine them. We can do the math. I just throw it in my calculator, okay? So x equals negative 5/4 plus or minus 1, whatever, either way, plus 1/4 will be negative 1. That's the negative 1. X equals negative 5/4 minus 1/4. If you throw that in your calculator, guys, that ends up being negative 3/2. Okay? Because you get negative 6/4 that would reduce to negative 3/2. Again, what does that mean? Since we got two answers that don't have a root in them, it means our original guy was factorable. Our A was 2, our C was 3, so factors of 6 that add to 5 would have been 2 and 3, and you would have done factor by grouping, 2x squared plus 2x plus 3x plus 3, and done all the math, and you would have gotten x plus 1 on one, and then 2x plus 3 on the other, and you would have solved it. All right, last one here. Again, we're not dividing by 2 because you were supposed to divide by 2. We're going to divide by 2 because our front number is 2, okay? So take everything and divide by 2. Oh, and I should be doing this too, guys. 0 should be divided by 2 as well. And I just mean if that was any other number. Like 0 divided by 2 is 0, but if that was like a 4, we're dividing everything by 2, okay? All right, so what happens? That 2 in front cancels out with the 2, so you're left with x squared minus 4x, and again, I'm going to do plus or minus blank equals negative 3/2 plus blank. Again, why am I doing that? Because 2 divided by 2 is 1, so x squared stays x squared. Negative 8 divided by 2 is negative 4, so negative 8x turns to negative 4x. And then 3 divided by 2 is just 3/2, but I want to move him to the other side. I want just the x's together. So since he's positive, I subtract him over, and I'm going to go ahead and start completing the square. All right, now I have it all set up, so how do I complete the square? I'm going to divide my 4 by 2, so you should get negative 2. Is that what I add to my line? No, I need to square it. So what is negative 2 times negative 2? Positive 4. Okay? And this one's not so bad. That's one that you could factor. What are factors of 4 that add up to negative 4? Negative 2 and negative 2. So look, he already told us what that left side was going to factor to. So this is x minus 2, the quantity squared. Over here, throw that in your calculator and hit math frac. So do negative 3/2 plus 4, and then hit math frac. Yep, so 5/2. All right, we've done it, guys. We've completed the square. We have a perfect square trinomial on the left equal to a constant on the right. So what we're going to do is we're going to take the square root of both sides, all right? So the left side, x minus 2, the quantity squared, square root is going to cancel. On the right-hand side, we have to take the square root of 5/2. And this is probably the hardest one, so I'll show you what we have to do here in a second. All right, on the left-hand side, the square and the square root undo each other. So whatever under there is what pops out. We have x minus 2. And then over here, we have plus or minus. This is not okay. And I want to I almost need to make a new worksheet. It's been so long. It's been a week now since we've done rationalizing the denominator. And I have the worksheets back to hand you. But remember, we can't have a root on the bottom. Like root 5 is fine on top, but root 2 on the bottom is not okay. So remember what you had to do? You had to invite enough friends, okay? So since it's a square root, we have to invite one more 2. But if we invite 1, 2 on the bottom, we have to invite 1, 2 on top. And you don't always have to do this. Like if that was a perfect square, like 16 over here, 4 would pop out. You don't have a root on the bottom. So try to break it down first. But 5 and 2 don't break down any further. So what's this end up being, guys? Well, what do we have on top? Root 5 times root 10, or 5 times root 2 is root 10. But on the bottom, who can pop out? A 2. Look how weird that is, okay? So my math lab would not accept plus or minus the square root of 5/2. Like, you cannot have a root in the denominator. But they're always going to be squares, guys, so just invite that friend over, the 2, the 3, whatever you had to divide by, okay? What's the last thing I need to do? I need to add that 2 over. When I add that 2 over, can he combine with the root 10 over 2? No. So your final answer is x equals 2 plus or minus root 10 over 2. And again, it's an ugly answer, but it's an actual number. 2 plus root 10 over 2 is something, and 2 minus root 10 over 2. I'm going to go do it real quick and see if we got it right. So I'm going to just try the plus one. Okay, so we have 2 in front. We have 2 in front because of that 2, and then I want to take x, which is 2 plus the square root of 10. I have to close off that because I want to make sure that just the 10's under the square root. Divided by 2 like that. I know it's ugly, but that's my x. 2 plus the square root of 10, but only 10's under the root, so you have to close that off. Divided by 2, what do I need to do to it? I need to square it. Minus 8 times x, which again is 2 plus the square root of 10. Close off the square root of 10 and divide that by 2. Plus 3. And when I hit enter, I hope I have 0. And I do. And again, they're ugly answers. Let me see what 2 plus the square root of 10 is. He's 3 something, okay? So he is a number. So 3.5-ish, when we put it in here, gets us our answer. And then 2 minus that is not quite a half. It's 0.4, okay? So this is just a nice